Hi, statistics kids. Right now, this video is about principles of experimental design. So it's the things that we want when we're doing an experiment and some definitions that we need to know. Okay, the first definition we have is something called a lurking variable. A lurking variable is a variable that is not among the explanatory variable or response, but may influence the response variable. We've talked about this already. So in the previous video, I talked about sleep, and I talked about how that could affect our grade. You maybe hear my son in the background slurping up his milk. I apologize. Okay. Now, one thing that could affect the grade that we're not measuring, okay, that could just be your general IQ. It could be what you ate. It could be how well you prepared. Sorry, my mouse is really not great right now, so forgive me. Okay. All right, let's keep going here. There are three principles of experimental design that are important if we want to draw causation, or if we want to establish causation, meaning one thing causes another, okay? So the first thing is control. Control for lurking variables that might affect the response. One way to do this is to use comparison groups, so you know the difference is from the treatment and not from lurking variables. Another way to control, if we control lurking variables, for example, up here, let's say, so what you ate also influences what your grade is. What we could do is we could say, okay, one group's going to get 5 hours of sleep and another group's going to get 8 hours of sleep. And we could make sure that they all have the same breakfast throughout the experiment. So what we're doing then is we're controlling this lurking variable. Okay, that's another way to control. Randomize. Randomizing is always good. And what we want is we want equivalent groups that are representative of the population. So when I break you up into group 5 and group 8, we don't want like all juniors in group 5, or we don't want all seniors in group 8, right? We want to have about approximately equal amount of juniors in the 5 hours of sleep group and equal amount of juniors in the 8 hours of sleep group. Same thing with seniors. We want equal amount of seniors in that approximately in the 5-hour group and equal amount in the 8-hour group. Again, we want to know that the that the response is because of the treatment here, how many hours of sleep you got, and not because one group had a ton of juniors in it and maybe they responded differently, okay? All right, randomize. Last one, use enough subjects. That's very important so we can trust our results. As we increase our sample size, our variation goes down, and that's really important in statistics. Okay, what are we hoping for? Okay, what are we hoping for at the end of this? We're hoping for significant results when we're doing an experiment. And what does that mean when we have significant results? Okay, so for example, let's say at the end of this study that we're talking about with sleep and grades, the 8-hour group, on average, they got a 90% on tests, but the 5-hour group, they got 89%. Is there a significant difference here? Did we get significant results? I'd say no. There's not much of a difference between 89 and 90. That would say, hey, sleep doesn't affect our grades. But let's pretend, what if this group got 90% as an average on a test, and this group got 60% on average of test? Is that significant? What does significant mean? Statistically significant means the observed effect, that difference there, is so large that it would rarely occur by chance. Rarely occur by chance. All right, let's keep cruising with a couple more important ones here. Kids just popped in to say hi really quick. They're very interested in the statistical terms. Say hi, everyone.
Hi.
Okay, you go shower. You go take a bath. See ya.
Subscribe.
Okay. All right, ladies and gentlemen, more terms. Placebo. What is a placebo? Okay, so we want to use the placebo in experiments, and that's one way that we can compare. So if we're asked for, principles of your random experiment, principles of your experimental design, one way we can control this, okay, is we can give a placebo pill in an experiment. So what is a placebo pill? Let's talk about that, okay? Or why do we use it? We use the placebo pill, okay, or a placebo to control the placebo effect, okay? To control the placebo effect. The reason we want to do it, okay, sorry, is we want to, forgive me here, my kids got me up. We want to make sure that people are getting the results, not just because they took like a Band-Aid, like that they took some medicine. We want to know that they actually feel better because they feel better, okay? What do I mean by that? I'm going to actually go to this new page. If I had 30 people who suffered from anxiety, okay, you can probably hear my kids right now, I'm sorry. Okay, and let's say we broke them up into 2 different groups. Okay, and we had group 1, and then we have group 2. And in group 1, we said, hey, just keep doing your normal thing. Okay, exercise or meditate or whatever. And group 2, actually, I'm gonna make an addendum. We're gonna tell all the 30 people that suffer from anxiety, we want you all to meditate, okay? But on top of that, okay, one group is just gonna meditate like normal, that's treatment 1. But the other one, treatment 2, they're gonna meditate and also take an antidepressant for anxiety, so a pill, okay? And then at the end of 10 weeks, we'll have them measure their anxiety levels. Now, the issue with this is, let's say that treatment 2 had more significant results, okay? All of a sudden, though, we don't know. Did treatment 2 have more significant results because they were taking medicine and that automatically made them feel better? That's that lurking variable right there of that placebo effect, okay? So what we do to control that is we actually give everyone a pill. So we'd say, hey, these 30 people, we're all gonna meditate still, but group 2 will get the actual pill, and group 1, they're gonna get a placebo pill. And that placebo pill, well, that is a sugar pill, okay? And that's used to control that placebo effect, okay? Now, I talked about this here. Don't worry about what I have here because I already talked about it. Another thing that we want to do when we're doing an experiment is, if we can, we want things to be single blind, or better yet, double blind. What does that mean? A single blind experiment means the subject does not know what treatment he or she is getting. Okay. So here in this case, if you were in treatment 1, okay, versus treatment 2, right? You would say, you don't know if you're getting the placebo pill or if you're getting the actual antidepressant. But me, as the statistician, I know what I'm giving you, okay? I know what I'm giving you. So again, treatment 1, treatment 2, you're the subject. You don't know which one you're getting. You don't know if it's the fake pill or the real pill, but I know which one I'm giving you, okay? That's not as great as a double blind one. A double blind is where I don't know what I'm giving you and you don't know what you're getting, okay? And the reason that we do that, ladies and gentlemen, is because then that really helps control bias. Let's say in this experiment, you were in the placebo group and I knew it as the statistician. I might ask you a question like, how are you feeling? Versus treatment 2 group, I might say, how are you feeling? Because I think it might help. But if I don't know, I'm not going to change the tone of my voice, even unconsciously, okay? Unconsciously, subconsciously, forgive me there, okay? Subconsciously. All right, ladies and gentlemen, single blind, double blind. And that is all I have for this video.